Okay, we're going to do two types of application problems here, and that will be it for today. It says a ball is thrown upward with an initial velocity of 18 meters per second. This might ring true of a little physics for you. And the height of the ball is modeled by the equation h of t is equal to 18t minus 4.9t squared. So if I look at that height, what type of shape does it make? And I'm wondering, what is the maximum height the ball reaches? Where does that maximum height occur? At the top. Vertex, thank you. And does anybody remember where the vertex occurs at? Okay. See, you guys are there's two important things that you're saying you don't realize. Number one, it happens at the top. At the top is where the derivative is equal to 0. Now, I'm going to show you something. Hopefully this will kind of bring some things together for you. It's pretty cool. But do you remember using this as a formula, negative b divided by 2a? Okay, just hold on, watch this. Okay, this is actually kind of cool. Okay, so that could be the equation for any parabola, right? And I said, if you look at the graph that we just drew, look at this graph. The derivative is equal to 0. So what's the derivative of this? Move the 2 in front. 2a times x plus b, set it equal to 0 and solve. All mathematics is connected. Okay, it's a beautiful thing. All right. Okay, so let's figure it out. What is the maximum height that the ball reached? Well, first I can figure out at what time it reached that height by taking the derivative and saying equal to 0. What is the derivative of 18t minus 4.9t squared? Or 9.8t is equal to 18. Or t is equal to 18 divided by 9.8. .84. Does that tell me the maximum height of the ball? How would I figure out the maximum height? Plug it into the derivative or the height function? Height function. So 18 times 1.84. $16.53. Do I give a label here? Meters. What is the height of the ball after 2 seconds? How would I figure that out? Nope, since it wants to know the height, I plug it into the original. I get 16.4 meters. Right, so the velocity, that I plug into the derivative. Velocity after 2 seconds would be, let's see, 18 minus 9.8 times 2. Will the answer be positive or negative? Why? It's on its way down. And I get negative 1.6. I need to have a label. Now, at what time would the ball have a height of 20 meters? Never. Why? Good. So how about this? What is the velocity when the ball has a height of 10? Now this was like 16.5 up there, so we're wondering when it has a height of 10, what's the velocity? That's what we're trying to figure out. It would help if I knew the time at which that happened, right? Can we figure out the time at which it happened? We'll do it after lunch. Go get some brain food, come back smarter. All right. Velocity when the ball is reached a height of 10. Velocity when the ball is reached a height of 10. Wouldn't it be nice to know what time it reached 10? And we knew what time it reached 10, then we can plug our time into the velocity function. So let's go to work. We've got a height of 10 is equal to 18t minus 4.9 t squared. Right? Yo. Because, yeah, it says h of t, height. Yep. So we want to solve this. I'm going to add the 4.9 t squared over the other side, subtract the 18t, and plus 10 equal to 0. How do I solve that kind of equation? Quadratic formula? Fortunately, I know this guy who makes YouTube videos. He made one. It takes 4 minutes and 2 seconds to type in your calculator. Everybody have it? Jill has it, right? Oh. Who's got it? 2.99 and 0.68. Okay, so there's my time. All right? So I know that those are the times where it reaches a height of 10. So 0.68 will be on the way up. 2.99 will be on the way down. We use the quadratic formula. So what I do now is I plug it into my velocity function. The velocity at 0.68 is equal to 18 minus 9.8 times 0.68. And the velocity at 2.99 seconds is equal to 18 minus 9.8 times 2.99. So those values should really be about the same. They would just be opposite in value. We've got 18 minus 9.8 times 0.68. And I get 11.34. So it'll be 11.34 meters per second on the way up. If we did this, we come up with negative 11.34 meters per second on the way down. So sometimes we gotta, there's multi-steps to it. So sometimes we might have to use both the height function as well as the velocity function. Okay. So our last example for today is in regard to economics. We talked about this yesterday. Who's taking economics right now? Nobody. Wow. 1, 2. We got 2, 3. Okay, raise your hand if you're taking AP Econ. Okay, so that's some of you. And then a lot of you take the regular Econ as well. Well, our economics application, we have a cost function, C of x. And we like to talk about a marginal cost function. The marginal cost function is C prime of x. And what C prime of x means is it is the approximate cost of producing the next item. Okay? It's the approximate cost of producing the next item. So we'll give you an example here. But that's the deal. So let's do a very basic example here. This company produces X number of shoes. The cost can be estimated by the following function. C of x equals 10,000 plus 5x plus 0.01 x squared. What is the marginal cost function? Marginal cost function is simply the derivative, C prime of x. And what is that? Good. It says, what is C prime of 500? So what do? Plug in 500. So we've got C prime of 500 is equal to 5 plus, and 2 hundredths times 500 will be 10 we get $15. So now we want to interpret what that C prime of 500 means. The cost of producing which set of shoes? The next one. What's the next one? Very good. Cost of producing the 501st pair of shoes is approximately $15. Now we want to compare C prime of 500, which is $15, with the actual cost of producing the 501st item. A lot of times people get confused how I figure this out. So we'll go back to our example, okay? Suppose Rachel pays $560 for 9 pair of shoes, but she pays $600 for 10 pair of shoes. How much did that 10th pair of shoes cost her? $40. So if we find out the cost of producing 501, we subtract that from the cost of 500, that will tell us the cost of the 501st item. So where do I plug 501 into? Into the original function. So let's do that. 10,000 plus 5 times 501 plus 0.01 times 500 plus 501 squared. And I get 15,015.01. That's the cost of producing 501 pair of shoes. Now I'm going to grab my same entry. I'm just going to go back. I'm going to change it from 501 to 500. And when I do that, I get 15,000. So that's a grand total of $15.01. So that's the actual cost. So was this a good estimation? Very good estimation. Okay. Thank you. I worked very hard. So this is your assignment. These are more kind of those velocity, gravity problems. And then these are going to be your econ problems. And there we have it. Tomorrow is an epic, epic, epic day. And I don't believe that you'll get an assignment tomorrow. Oh yeah, tomorrow we have Powder Puff,